Hey everyone, I'm back again. This is day 9. I'm going through the example that I've created, explaining some of the design patterns and some good practices to create some agents. So I've implemented these things, like first of all choosing the good model for perfect use case, for our use case, like perfect model for that, and then design patterns like orchestration, memory, and then tool calling and callbacks. So, I've gone through some of these, but I'll show you the example as well. So these are some patterns for the AI agents, and we'll go through how we can have memories, parallelization, and few things that I've implemented here. So let's go through the demo. First of all, so I've created a travel itinerary agent. What it will do is just ask you where you want to go and ask your preferences. I've given some preferences. It will go ahead and trigger some memory and store our preferences, so that it can look up those things, and our sub agents can look up those things and understand what's going on. Then it will. So let me show you first the example of what I have created. This is the architecture. So I have a travel itinerary planner. It has 6 agents. First is the destination research agent, and then budget planner, synthesizer, flight agent, hotel agent, and activities agent. So each of these agents are having some APIs which are real world APIs. For flight I'm using booking.com, for hotels I'm using Expedia, for activities I'm using I think Ticketmaster's API. All of these are API that I've added. I'll show you the example for one of them. So yeah, so it has asked for my preferences. Also, one thing to note is we have added the memory tools to some of the agents here. For synthesizer it is having a memory tool, and these kind of stuff. For activity we have given memory. So all of these agents are having access to memory as well. So okay, it has asked for the preferences, stored it in the memory, and I've just played along all those things like choose this, choose that, this is the budget, increase the budget, those kind of stuff. So, and went ahead and checked the flight. So it checked up the flight. This is the agent call that's happening, and it checked up the flight. This is the result. Gave me a few options. I chose the option, and then hotel lookup, similar thing. Yeah. So for activities as well, it went ahead, asked me for what kind of preferences I have, and created the activity around that. You can check the code in the GitHub, but I'll go through it once more. So this is, so I've asked what's in the memory at the end, and this is the exact thing that's in the memory right now. So let's see the code. This is our D9 travel agent. This is the root agent that we have created, which is having all the prompts, all the strategies, how to use the tools, and how to have parallel agents. So we are having these agents as parallel agents that they can call, and these agents have tools. Again, it has memory tools, and the 4 agent callback, which is having initialized memory. This initialized memory is like let's say init to an object, which is having initializing the entire state of the context. And yeah, these are other tools. Let me show you another example of, let's say, a sub agent like flight agent. For this we are having these 2 tools, which is the memory and the flight lookup, giving the prompt of how to use these tools. And the flight lookup is having the API client, the entire input schema, which everything we have given the prompt for the sub agent, and we are using this actor, these kind of stuff. It's just API code, and yeah, this is how it's implementing the memory. So memory is like pretty cool stuff, which we can use, having a shared memory between agents, and if the context overflows, we can have summarization in the memory itself. So okay, I hope you guys are liking this. I hope you guys are getting value out of this. So I see you guys in the next one. Bye.